Hi, welcome to the lecture on Chapter 7. Now this chapter is basically going to go through all the wireless LAN protocols, kind of give you history into why they were done and some of the techniques that were applied to it. It's more of a history lesson, but it also gives you a peek as to what the protocol writers were thinking. You know, they created one and said, I need to speed it up. I need to do something different. Give you ideas what types of things they did and why and how they did it. So I think it's more of a history lesson. Yeah, you're going to get quizzed on this stuff, but as far as a lecture, a lot of it's just read the stuff through and go through it and just be ready to test on it. So I'm going to look at explaining the differences between 802.11g and B. Look at how 802.11a works and how it differs between other 802.11 networks. Look at what most of us will probably have in our house with the 802.11n and how it operates. Look at some of the futuristic ones that come in the AC, 802.11ac and 802.11ad, and then other amendments that are currently being worked on. So all of these come into play. So when you look at 802.11g, it's been out quite a while. A lot of the main drivers here was basically what? I'm looking for faster speed. When you look at some of the older ones like 802.11b, it only supported up to 54 megabits, but it had a fixed rate. So if you had a computer in and running 54 and somebody came in that only had a network interface card of 6, guess what? Boom. Everybody dropped down and running at 6, and it locked a lot of problems. But now you got 802.11g. It says now I can have different layers. But it also, 802.11g says, hey, what happens if I, instead of just sending out one signal on one frequency, what happens if I split it? Maybe not as running as fast, but if I can split it, run them in parallel, that it'll help communication, help the quality of communication along with maybe the speed. And the product they came up with, or the design they came up with, orthogonal frequency division multiplexing, which basically splits the digital signal over several smaller ones running in parallel. And it uses like 52 subchannels that it runs. Now, 4 of them are only used to support signal strength, and the other 48 are used for data. Just so it gives you a rough idea of what the 802.11g physical layer looked like as far as how these subcarriers were laid out and how they were used. Now, the reason they did this because they says, hey, especially in a wireless environment, the signal gets bounced around a lot and it gets distorted. And if I can get the antennas to receive from different signals, different places, different times, I can kind of allow that multi-path distortion to kind of help me understand and create a better signal, or at least reception. So just a pictorial of what looked like between like B and G. I'm not sending one signal. I'm sending it a little bit slower across 4 different, multiple different subcarriers. And like I said, in 802.11b, it was mandatory. I had fixed, had to use by everybody, must be supported. Now, OFDM supports only 802.11g, but at least give you an idea of that, hey, if I can split my signals, it gave them an idea what to do. Now, there are some optional transmission codes to help to at least to increase the speed, but just know that they exist. So it really says here, I got the preamble to lay the clock rate is set, because now I've got to worry about how much speed everything is running through. So the signal time differences in 802.11b, there was a 6 microsecond quiet time where no transmission could be added. So it just kind of had to delay everything just a little bit, just to let everything quiet down. Now, that timing is that short interface space, that SIFS timing. It was used to, affected that additional quiet time and increased the performance a little bit. It cut it down a little bit just because a little bit of overhead, because 802A didn't have it. So it cut the quality down, but it increased the performance quite a lot. Now 802, whoops, one too many. There you go. 802G does not require this quiet time. So you can start seeing that A had problems, so B did something, added the quiet time to make things a little bit easier. G says, well, I'm wasting efficiency, so I'm going to take that quiet time out as I increase the importance, allowing me to use actually some of the same formatting. So now I got compatibility between different protocols, at least between B and G. And if you look at some of those old wireless access point, they were sold as B and G, modem. It was part of the advertising protocol. Now, at the MAC level of the 802.11g program, there had to be some changes. It included changes that slightly increased the performance by submitting the entire frame over OFDM. So now I'm using that slower technology, but at least I'm now starting to see how they work, different technologies, different ideas, and start to move into a more consistent protocol as we make it. So I saw a problem, I fixed it, see a problem, fix it, and make sure I got backward compatibility and things into different protocols. Now to accomplish this speed up, I had to have this clear to send that we've seen talked about in previous lectures. So now you got to say, hey, I got this clear to send, is transmitted with a destination. Where do I want to send it to? And the purpose is to act as kind of a protection mechanism to notify older devices. Don't try to attempt to understand, this support frame. Now, 802.11a, now the standard maintained the same median access as far as speeds are concerned, but it was all the differences are now confined to the physical layer. Now, 802.11a achieved its speed over B by the use of OFDM and a little bit better error correction scheme. Now, 802.11a operates at a little different frequency, the unlicensed band, definitely for shorter range, higher speed access. It was segmented only to 4 bands, but it gave about 7 times the bandwidth available, or 7 times that was available to 802.11b. So I could larger data, shorter distances, so give you a rough idea between the different frequency bands and how 802.11a was, processed. It just kind of gives you an idea of how they were differently laid out. So less overlap. So now this is when you talk about A and B versus A. You look at how many, I'm using 8 of 23 channels in this configuration. B and G, you had to have, these couldn't be duplicated. I couldn't use every single channel because of interference. Now I'm using something a little bit different. Now I'm using multiple channels, but a higher speed, lower rate. So now I got different techniques, and this is where they start saying, how do I now modulate my signal to get more and more data on lists? So they came up with, and you've seen these terms before, but, frequency shift keying, quadrature phase shift keying, 64 level, and basically it means what? How much data on one bit, one set of, one data point, how much data can I submit? So as they keep changing how they were able to modify, so now I can say, oh, I've got a bit by changing the amplitude and the starting point of a wave, I can identify which bit combinations there were. And it gets really crazy when you get into, 64, but it basically says I'm changing the amplitude, I'm changing the starting points, I'm using frequency, modulate. So it allowed me to increase the speed and how much data was being sent just by the modulation characteristics. So I got to well beyond the 54 megabit data range that was some of the B and G limitations. Header format changed a little bit. Error correction between A and G changed. Definitely changed it different from B, because now that I got parallel subcarriers, I don't have to worry about it as much. So now I got a few extra bits for forward error correction, FEC. But then it's like, okay, now what can I do to now increase that speed? Back in 2009, 802.11n came into place. Now, this started using multiple antennas along with multiple radios in each device to take advantage of that multipath interference, to kind of increase that signal-to-noise ratio, get me above this. But it also worked at two different frequency bands, both 2.4 gigahertz and 5 gigahertz. So it made it backward compatible to 802.11a. Now, what am I doing? It uses, hey, I'm now to do this, since I got multiple antennas, multiple antennas, now I can use antenna diversity. And basically it says, hey, I'm going to receive what's my strongest signal. So you got multiple antennas, so I got multiple inputs, multiple output, MIMO. Multiple inputs, multiple outputs. So now I'm employing a beamforming technique. So I'm going to direct my transmission. I'm using spatial multiplexing, because as frames are broken up, I can send to multiple parts, different radios. So it allows me to pick up different information, because it's going to bounce off different things and allows me to use what the environment is telling me to kind of give me a more secure, a little bit. I'm sending less data across each one, so now I can speed up the data processing. Now, 802.11n specifies radio configuration using multiple transmitters and receivers called radio chains. It can use up to 4 transmitters, 4 receivers, with a maximum speed of like 600 megabits. Back when 802.11n, I don't know if I ever saw a 600 megabit N, at least not, you couldn't go to Best Buy and buy it. You can probably get up to 300 at that time. So it just says they could allow multiple transmitters, multiple receiver, and be able to increase that data throw. And just give you a rough idea of what it physically looked. Most of us probably don't have 3 antennas on ours. But this MIMO and beamforming allowed me to to be able to use that spatial multiplexing to increase both the range and the reliability. Maybe not, and of course also the speed, but it also allowed me to just improve the quality of the system. So it allows me to take advantages, advertise a device during the association. So it says, hey, which devices are connected when I hook up to that wireless LAN? So 802.11 uses more bandwidth than other standards, so it can use 20 or 22 megahertz with A or B or G, but if it uses 40 megahertz, now I can get up to these 300 to 600. And like I said, I don't know if I ever saw one on the market commercially at 600. I think the highest one I purchased was probably at the 300. It supports different types of modulation techniques, but it also supports something called channel bonding, where you get 2 channels are combined. So I got 2 20s combined into a 40. Just to give you a rough idea what that kind of looks like, you got non-overlapping 20s, but you could combine them and get an overlap of a 40. Now, you may see something called a guard interval. And basically what that is a delay required between each frame to make sure that reflected signals arrive in time. And it prevents inter-symbol interference. So having that guard interval helps. Now, the modulation encoding sets in 802.11 uses a combination of 9 different factors. I'm not going to make you remember all 9 factors, but just know that to get those up, speeds up, you can go through. Now, it supports 3 different frame formats. And if you had an 802.11n, you could set it up to be anything, old ones, 802.11a and G, N only. And I usually forced everybody 802.11n. If you come into my house with a B and G, you weren't allowed to get on. But it definitely gave me higher speed, long range, because if I allowed some of the slower devices come in, the second they came in, my speed, my range, everything dropped to that level. Now, this channel configuration, this HT Max sublater, it allows me to increase throughput and manage power a little bit better. It does that with the frame aggregation that allows me to combine multiple MAC frames. 2 new power management, so now I get the spatial multiplexing save, and I get power save multi-pole, which I can turn on and off all but one radio. So it allows me to control how many radios are in play. It reduced the amount of interframe space interference, but it's used only in that greenfield mode, which is that N only option. Now, some channel configurations with N's. It allowed N to coexist with some of the older models, but it says, hey, 0 says green mode supports only devices 20 and 40. So it allowed me to pick and choose since I had 2 groups of channels that I could play with, it allows me to which ones I'm going to use. Now, the latest one I've purchased is an 802.11ac. Now it says I'm not splitting between 2.4 and 5. I just taken 5. It uses more bandwidth, but even wider channels, but allows me more subcarriers to transmit more data. So now I'm using between 80 and 60 megahertz channels, but now I've got a whole lot more subcarriers and some pilot subcarriers. So it allows me to increase my data rates from anywhere from 433 megabits to close to 6 gigabits. It's now telling you that we've switched gears to the now point. I'm getting to the point where wireless is getting close to landline potential. And now it's got a name of very high throughput, but it allows between 2 and 8 radios. So I've increased the number of radios to allow this spatial streaming per AP. Not all are being used at the same time, but just know that it hits multi-user MIMO. So now I can control more of what I want to do. I can stream it to different devices, control it differently, but it gives me more power, more threshold. Then you got A and D. You get into newer ones that I haven't actually looked to see if these are commercially available yet. But here you've got Wireless Gigabit Alliance. So now you got AD are trying to say, hey, I want to get more interest. Now, here, the faster I go, my range starts dropping off. So now it's at 6 feet, maximum range of 33. Now you see this was probably what your range of other technologies you've seen, but it's now starting to get me to getting more speed. Now 802.11, we've published it in 2005, but allows me to, send and receive devices of bursting of data of information. So just kind of says I'm not sending everything at one time. I'm just busting things up, sending multiple frames at a time. And you've seen this more in a Ethernet arrangement than we have in wireless in the past. It does have a couple more coordination functions, enhanced and hybrid coordination functions. But it just says, hey, I want to enhance, I want to give a higher priority, and just kind of waits less amount of time. The hybrid kind of says, hey, it's a combination of this and a point coordination. So it allows me now to support quality of service to improve, mobile devices and users. So it kind of, now 802.11r, it says amount of time required by devices to associate and disassociate. So I'm trying to speed up how fast people can get in and out of this. Now you can use voice over wireless LAN. So you've probably seen some of that option.
designed to resolve some of the issues with security, handoff, enhance convergence of voice data and video. 802.11s, you're seeing entire download of downtown area of a medium-sized city. So now you're looking at how do I handle our area, metropolitan area networks, works in wireless MET networks. I'm going to double check if this campus is using some of this. Since we have so many access point cover this, I'll have to look at which way they've got some of that set up. Now there's other deployments, AF, AH. A lot of them are just saying I'm looking for lower data rates but greater distances. I'm looking for frequencies that I can support internet connectivity, AX, AY. So all of these are things that are trying to say I'm trying to develop new technology, take advantage of things we've learned, enhance where the detriments are to get, speeds up to 4 gigahertz, up to 350 meters. So they're expecting the standard to be available probably supposedly last year. Have not followed up to see if that happened, but it still gives me gigabit transmission for longer range, so it allows me to do a lot more. So just knowing that you've seen wireless came out in the 90s to what we see today, to go from as little as 2 or 3 megabit transmission rates to now the gigabit range, it is pretty impressive. So hopefully this gives you a rough idea of how the wireless protocols have changed, and hopefully that you've learned a few things. So if you have any questions, give me a call. Have a nice day. Bye-bye.